Hello students, we'll start the numerical on keys. We have seen keys are having two formulation. So first one is shear failure, that we have calculated tau is equal to 2mt by dBl, and for crushing failure 4mt by dHl. So how it can come, that I told you, and we have seen that derivation also. Now we'll see the numerical. So I'll read the numerical. It is required to design a square key, important square key. So where there is a square key, it means that B is equal to H is equal to D by 4. Very important. For fixing gear on a shaft of 25 mm diameter. So given data I'll write while reading. D is equal to 25 mm diameter of shaft. The shaft transmitting 15 kilowatt power. Power is equal to 15 kilowatt at 720 rpm, small n, 720 rpm. The keys are made up of steel having yield strength 460 SYT. I'll write SYT 460 Newton per mm square, and factor of safety FOS 3. For key material, yield strength in compression can be assumed to equal yield strength in tension. So it means I'll write SYC, yield strength in compression, is equal to SYT, yield strength in tension. So this will be the condition I'll explain. Determine dimensions of the key. Now I told you what are the dimensions of the key, nothing but it is B into H into L. So that we need to find out. That is called as a design of the key. So while reading the numerical, you have to focus like this. Write the given data carefully and read the given data carefully and understand the numerical. So one by one we'll move for the solution. So these are the given data. So I'll start with the step number 1. Step number 1 for calculating, that is, always remember, step number 1 is need to calculate the permissible stress. So I'll write calculate permissible stress. Now while calculating permissible stress, there are only two kinds of the stresses are available for the keys. One is crushing, another is shear. So we'll calculate shear stress. Tau is equal to, we know, 0.5 of SYT by factor of safety. Now 0.5 SYT is given how much? 460 divided by factor of safety 3. So through which I'll just try to calculate from your side, use calc. So shear stress occur, that is permissible shear stress, 76.67 Newton per mm square. This is for permissible first, that is shear. Then second, crushing failure, as they have mentioned, it is SYC by factor of safety, that is yield strength in compression divided by factor of safety. Now yield strength, they have mentioned one condition, that for key material, yield strength in compression can be assumed to be equal to yield strength in tension. So I can write SYC is equal to SYT. Therefore SYT how much? 460 divided by factor of safety 3. So I'll get here crushing failure occur 153.3 Newton per mm square. So this will be the value for the crushing stress we have got. This is your step number 1. Then step number 2, very important. While calculating the step number 2, you need to find out, as I told you, we'll move toward as like a shaft, torque developed by the key. Correct? Torque transmitted by the shaft. Torque transmitted by the shaft we'll have to find. So I'll write torque transmitted by shaft. So we know torque transmitted by shaft, that is mt is equal to 60 into 10 raised to 6. This is power divided by 2 pi n, which is equal to, now 60 into 10 raised to 6, power is given or not, you can just check, 15 kilowatt, that is 15 divided by 2 pi n rpm 720. So by putting this value, I'll get the torque transmitted by the shaft is, just try to calculate from your side, and it is 198,943.5 Newton mm. So it is around this much torque will be transmitted by the shaft, or I can say 198 kilonewton mm. So that will be the torque. As I told you, this is a square key type, square. So square indicates B is equal to D is equal to, sorry, B is equal to H is equal to D by 4. In this case, D is given or not, we'll have to check. Diameter of shaft, they have mentioned 25. So it is 25 by 4, around 6.25 mm it will come. We'll have to take, which is nearly equal to 6 mm, because this is for key, correct? Key width. So 6 mm we need to consider, that is B. So half portion we done, that B and H we have calculated. Now the dimension of the keys L is remain, length of keys remain on the basis of stress. So for that, first of all, I'll consider according to shear failure. According to shear failure, I will consider, that is, we know tau is equal to 2 mt by dBl. This will be the equation. Here I can write L is equal to 2 mt by dB tau. So mt we have calculated. I can multiply 2 into how much? 198 into 10 raised to 3 divided by, so D is nothing but 6. Now while considering the width, I will have to consider width, whether they have given or not, we'll have to check. So D is equal to, so B is equal to, see here B 6 I have put here. So D is nothing but diameter. So that is D is a diameter of shaft 25 into shear stress occur 76.67, correct? 76.67. So this will be the length for the shear failure. So after calculating this, we'll get L is equal to 34.6 mm, and this is length nearly equal to 35 mm. So this is according to shear failure. According to crushing failure, we know sigma C is equal to 4 mt by dHl. Therefore L is equal to 4 mt by dH sigma C. So here 4 into 198 into 10 raised to 3 divided by D is 6 into H is also 6 into sigma C. How much we have calculated? 153, correct? So through which we'll get the length for key. In case of the crushing failure, it is again, so see here is 153 point something, and D is nothing but 6, H is nothing but 6, and D is 25. D is 25. So here we'll get 34.6 mm, which is again nearly equal to 35 mm, which will be the final length by considering the stresses. So likewise we need to solve the numerical related to keys, and very simple, as like a shaft we have designed. The first step is permissible stress, second one with the calculation of the torque, and third one with the calculation of the BHL as per the stresses point of view. I hope you understood this. Thank you.